Software-Defined Networks, SDNs, and Security Considerations. Welcome to this lesson on Software-Defined Networks, SDNs, and Security Considerations. Traditional networks rely on hardware-based controls which can be complex to manage and scale. Software-Defined Networking, SDNs, simplifies network management by using centralized control through software, allowing dynamic configuration, automation, and enhanced security. However, SDNs also introduce new security challenges, such as controller vulnerabilities and potential misconfigurations. In this lesson, we will explore how SDNs work, their security risks, and best practices for securing SDN environments. Let's get started. Software-Defined Networking, SDN, is an approach that separates the network's control plane from the data plane, allowing administrators to manage network behavior programmatically. Unlike traditional networking, where switches and routers make independent decisions, SDN centralizes network control in a software-based controller. Think of SDN like air traffic control for a busy airport. Instead of each pilot making independent decisions, air traffic controllers oversee all flights, ensuring efficiency and safety. Similarly, SDN enables a centralized controller to direct all network traffic, making it easier to optimize performance and apply security policies. For example, a global enterprise using SDN can automatically reroute traffic during a network failure, reducing downtime and improving resilience. Here's how to implement SDN securely. Use encrypted communication between SDN controllers and network devices. Apply role-based access control to limit administrative privileges. Monitor SDN traffic for anomalies and unauthorized changes. Understanding SDN architecture is essential for securing it effectively. SDN consists of three primary components: the application layer, control layer, and data layer. First, the application layer. This is where network applications like firewalls and load balancers interact with the SDN controller. Second, the control layer. The SDN controller acts as the brain of the network, managing all routing and traffic decisions. Third, the data layer. This includes the physical and virtual network devices such as switches and routers, which forward packets based on the controller's instructions. For example, in a cloud data center, an SDN controller can dynamically allocate bandwidth to virtual machines based on real-time demand. Here's how to secure each SDN layer. Apply strict authentication to the application layer to prevent unauthorized access. Secure the control layer using encrypted communication and redundancy. Implement intrusion detection for the data layer to identify potential threats. While SDN offers flexibility and automation, it also introduces new security risks that attackers can exploit. First, SDN controller vulnerabilities. Since the SDN controller manages the entire network, a compromised controller can allow attackers to manipulate or disable network traffic. Second, API and interface security risks. SDN relies on APIs to communicate between layers, but if these APIs are poorly secured, attackers can exploit them to gain unauthorized control. Third, man-in-the-middle attacks. If an attacker intercepts communication between the SDN controller and switches, they can alter traffic flows, rerouting data, or injecting malicious commands. For example, a cybercriminal exploiting an SDN API vulnerability could gain control over the entire network, redirecting sensitive data to an unauthorized server. Here's how to mitigate SDN security risks. Use multi-factor authentication, MFA, for SDN controllers to prevent unauthorized access. Encrypt API communications to protect against interception and injection attacks. Implement regular security audits to identify and patch SDN vulnerabilities. Because SDN controllers and APIs are central to network management, securing them is a top priority. First, use access control lists to restrict who can interact with the SDN controller. Only authorized users and applications should be allowed to make network changes. Second, implement API security measures such as rate limiting and authentication tokens to prevent abuse and unauthorized API calls. Third, segment SDN controllers from other network components to minimize exposure. Placing controllers in a dedicated security zone reduces the risk of attacks spreading. For example, a financial institution using SDN should enforce strong API authentication and isolate SDN controllers from internet-facing applications. Here's how to protect SDN controllers and APIs. Use strong authentication and role-based access controls. Monitor API activity logs to detect suspicious requests. Isolate SDN controllers from less secure network segments. Let's look at a real-world example of how SDN enhances security in a cloud environment. A major cloud provider adopted SDN to improve network scalability and security. However, early security assessments revealed vulnerabilities in API access and controller authentication. To address these risks, the provider implemented multi-factor authentication for all SDN administrators, encrypted API communication, and deployed an anomaly detection system to monitor network traffic. As a result, the provider strengthened its security posture, preventing unauthorized access and ensuring stable network operations. Here's how to apply SDN security measures effectively. Enforce strict authentication for SDN administrators and APIs. Encrypt all SDN control plane communications to prevent interception. Use continuous monitoring to detect and respond to network threats. Now, let's summarize what we've learned about software-defined networks, SDNs, and their security considerations. SDN separates the control and data planes, allowing for centralized network management. Key SDN components include the application layer, control layer, and data layer. Security risks include controller vulnerabilities, API exploitation, and man-in-the-middle attacks. Protecting SDN controllers, encrypting communications, and enforcing API security are critical security measures. Organizations should continuously monitor and audit SDN environments to detect and mitigate threats. By securing SDN architectures, businesses can leverage software-defined networking's flexibility while reducing security risks. This concludes our module on software-defined networks, SDNs, and security considerations.